Everyone, my name is Daniel Gorelkin, and we are doing the code review for the CS 499 class at the Southern New Hampshire University. This code review will focus in three main sections. The first category will be the software design and engineering. The second one will be algorithm and data structure, and ultimately that's going to be the database under review. So this code was developed initially for the CS465 class. Essentially, that's a mean stack application written in JavaScript and consists of a handlebar templating with some CSS file, obviously structured as a MVC model view controller structure and connected to a locally hosted MongoDB database. Over the time, with some enhancements to come, that database will be scaled up to the cloud version, the MongoDB Atlas, and we'll get way more modifications like a live cart, some additional functionality, and so on. For now, I will be focusing in the review of the homepage, which consists of some images, links, and the travel page, which gets all its data directly from the database through a RESTful API. Yeah. Okay, so let's dive into the code and let's see what's going on under the hood. So here we can see several files such as the style CSS, which serves the style sheet for the project, for the homepage and all the rest of the pages. We've got the index JavaScript file, which is the controller for the homepage, and the index HPS file, which is generally the skeleton for the homepage and renders the data through the handlebars templating. Additionally, we've got the header and footer files, which are shared between all the website pages. So looking at this piece of code, the index HPS, we can see a nice structure. However, what bothered me the most is the lack of clear communication and documentation. For example, I would suggest adding a comment at the head saying, hey, that's your piece of code, that's what it does, and that's its purpose in life. Similarly, we've got few blocks here. For example, we got the header block, we got the main block, we got the testimonials as the sidebar. Each of these blocks should be neatly commented and explained what its purpose and what it should do and which section of the page it should control. Another issue that bothers me a lot is the lack of comments explaining what is the data structure, what is the how's the data that coming from the API looks. For example, we are getting our data through an API. So let's see how our data looks like. Okay, so we know we will get JSON that contains the heading as a string, heading text as a string, the block is a string, and some entries for the blog and some entries posted for the testimonials as an array. Going back, I'll be happy to see an explanation saying, hey, your content gonna look like that. You should expect to get content of heading, type of string, text type of string, and so on and so on, which clearly explains to the developers that will maintain the code that's the type of data you should expecting to. Same thing I would do for the testimonials and same thing for the sidebar section. Another issue that kind of bothers me is the lack of comments saying, explaining what type of data expectation we should expect. So we know we'll get data embedded here, we got some data here, and we got some um, data coming here as a for each loop. However, me or any developer that will maintain that code has no idea what this data should looks like. So what we can do is to go to our API and take a look how that data will get there. So we know we get strings for the heading text. We got the latest blog as a string and some blog entries array, same as the testimonials array. So something we can do is to place some comment here saying, hey, that's how our data should look like. So you will get a heading as a string and heading text as a string and some blog entries as an array and testimonials and so on and so on. This will let know what type of data we should at least expect to hear in this handlebars templating. Another issue that I noticed that is this for loop block is missing an empty array check mechanism. For example, assuming that our array arrives an empty one or even a null or undefined, we'll get a problem. So what we can do is to define an else statement that will say um, something like this. Hey, our blog entries are empty and no entries available at the moment, right? Another defensive programming technique will be to take care of a scenario where images cannot be loaded. For example, if for some reason we cannot pull this image or it doesn't load or it's null or it's missing whatsoever, the end result will be that we'll get this tiny ugly error on our website. So what we can do to resolve it is to define a state saying, hey, in case this image doesn't load, please go to the images directory and pull out the C sound image by default, for example. Right? So in case of error or the image is null, please load the C sound images. What this will do is get our website, pull the image as we defined. Lastly, another issue I would like to address is hiding right here in these triple braces. Now, because I developed this code and I used the triple braces to push raw HTML through, I actually created a cross-scripting risk, which means malicious software and bad code can be pushed through these triple braces. So obviously, the right thing to do will be to make sure that the data is sanitized server side, but at least the least we can do is to use a double braces that will prevent raw HTML to get through and will make our code more secure. Okay, so clearly we're not done yet with this file, and there is way more to be done here to clean it up. But let's jump to the index JavaScript file, which is our controller, and take a look what's going to go inside. So first and foremost, I can see an issue with our documentation here, and we can easily modify and make this comment more clear, explaining what this piece of code does and what its purpose in life is. Secondly, when I developed this code, it was initially built for a static website, for a static web page. And later, it was modified to be used for an API endpoint. And clearly, I forgot to remove this redundant piece of code. So this one is gone. To proceed with, we've got this console log that displays some message, which is really handy for debugging. However, for production deployment, there is no real need it to be displayed and showed. Next, our database. Our database is running from the local host and it was already shifted to the cloud database version, the Atlas, and our connection string was disguised in the environment variables for safety and security issues. So there is no real need to keep the local host address running in the production. So we should remove this one as well. Another issue I would like to address is this out of bounds risk. Means if for some reason our array is null or doesn't exist, or we out of bounds reading from this array, we will get an error. So what we can do is to return an empty array, rather saying empty dictionary, in case our array is null, gives us some error. Additionally, one more small yet important tweak we can consider is in our response message through the error handler. So in case the error handler will be triggered, it might return expose some internal sensitive information to clients or the user. So to prevent this, what we can do is to disguise the error message, returning just a simple string instead the message itself. Right, so now the returned information will be a string saying internal server error instead of the real error information. Moving forward, we will review our style sheet to see how our website and our homepage behaves under several different screen sizes, for example, a full-size laptop or a mobile smartphone device. So clearly, we can see a lack of clear comments explaining which section of code does what, and that should be taken care of. Moving forward and inspecting the website, we can see that although the page is properly displayed on a large screen, reviewing the page from a mobile device will reveal a poor design that has not been considered for the small screen users in mind. Hence, running the available developmental tool will show the page be poorly arranged and not appealing to the user due to fixed white desktop layout which breaks on mobile. Hence, we should modify the page to have modern responsive strategy in mind by modifying the style sheet file with fluid containers and responsive design. Additionally, we should consider defining a clear and concise comment headers for each block in the CSS file to make it more easily readable for the next developer to come. With that said, implementing the enhancement mentioned above will demonstrate clear demonstration and communication skills by communicating best practices for maintainable code and offensive programming, while recognizing risks, avoiding error, and having security awareness in mind by implementing testing and debugging techniques and demonstrating web development skills. Those enhancements will directly relate to and demonstrate the ability to use well-founded and innovative techniques and tools in computing practice and accomplish industry-specific goals while developing a secure mindset that ensures privacy and enhance security of data and resources. So, for the second part, I will be focusing on algorithms and data structure. In this section, under the Algorithms and Data Structures rubric, we will focus on performance and algorithms that read the data from the database through an API endpoint and render the data on the Travlr page. So mainly, we'll be focusing in this Travlr page, which displays some packages from the database and presents it to the user. For doing so, we'll be looking at several files, mainly the Travlr API, which serves as the root for the API address, the Travlr API controller, which gets the data from the database and returns it as a JSON type, the Travlr.js, which serves as the controller for rendering the information on the screen, and lastly the Travlr HBS file, which serves as a skeleton for the HTML page, the Travlr. So to begin with, we will start from the Travlr API controller code. Generally, we can see a clear structure. The code contains mainly the all trips list function and the find trip. We can see some comments, however, slight modifications and um, clean of the code should be done, like this section, for example. This comment should be removed, and some other comments should be modified to display which uh, what each of the function does, what the values it gets, and what the values it returns. Nevertheless, the all trips function, for example, getting a call to the database and getting all the information through the find method. Essentially, if the call is successful and the data exists, it will return a 200 status, which is all good, and the query itself in a type of JSON, the JSON type. From there, the data will be passed to the Travlr HBS code, which essentially a skeleton. We can see clear comments. Mainly, we can see that for each loop, that will render the trips. This function, for each trip loop, works with the ON time complexity to render the trips. This means that from an algorithm standpoint, the rendering cost grows linearly with the number of trips grows. Therefore, the more trip instances we retrieve from the database, the longer it will take the app to load the page. Similarly, the code on Travlr API contains the findTrip function, which returns the first instance of the trip searched by the trip code and returns only one item if such was found. For example, going to our Travlr page and searching for the specific travel package, for example, DAWR some ID, that's supposed to be a specific package, and the query will return one and only one trip instance from the database. We might have several, but the return JSON will contain only one file. Since we already defined some indexing for the type of query in our schema, more about it in the database section next. The algorithms run a binary search, which works by continuously halving the search space until the target element is found with the O log n efficiency, which is considered to be highly effective. Hence, rendering the loading efficiency of the page for this scenario is considered to be O1, which means instantaneous. Hence, from the algorithmic standpoint, the code is considered to be practical and there are no major algorithmic inefficiencies. However, some improvements could still be implemented. One of the issues that bothers me the most is that in the long run, as the volume of trips scales up, retrieving the entire dataset and rendering thousands of trips on one page with the ON linear complexity might be inefficient and overwhelming. For example, going back to our website and requesting to get all the results for the API for the travel page will return a long JSON file. In our scenario, we have only 4 trips. But again, as the website scales up, that will be thousands of trips returned from the database. Therefore, we might want to split the results into several subsets and apply pagination to address this issue. As a result, instead of loading thousands of results all at once, the system will present a limited number like 10 or 25 results per page, which will then reduce initial load time and improve the user experience, making it easier to browse the page and faster load time. This could be done by easily modifying this find query as follows. Next, we will test the pagination parameters. So we'll do it as follows. We will limit our results to 2 and we will skip the following 0 results. Now we will add some parameters to update call via our API. It's going to be parse it query limit or by default let's make it 2. And let's define the parameters for the skip pages, skip 0 pages by default. Now we will swap our hard-coded parameters to read the parameter through our API. Next, we will test our functionality through Postman. by saying, hey, I want to get two results per page, which means the first page, and we're gonna get two results. For the second page, for example, we're gonna skip the first two parameters and get the third and fourth parameters by saying, hey, skip the first two and get me two more. And that will return us the next third and fourth parameters for the page. In such a way, we can defy pagination and show limited number of results per each page. Similarly, we will test that functionality directly from our website. So we will go to our website, our API, and say, I want to get one result and skip the first three. As expected, you'll get only one result that shows only the specific query, specific trip as we requested. In such a way, we can significantly improve our complexity from being ON, let's say 0,000, to on 10 results per page, which will significantly improve the speed and the performance of our website. With that said, the mentioned above file would benefit from a design review such as a minor redundant code cleanups and can be seen in the Travlr JavaScript file, proper comments and documentation in the Travlr HPS file. Several enhancements of the data structure and algorithms such as applying the paging technique and making sure that the endpoints return the desired results. Ultimately, the mentioned enhancements will demonstrate efficient algorithmic principles and data structure optimization in line with the course outcomes such as solving a given problem using algorithmic principles and computer science practices with efficient algorithmic design and the use of innovation tools to achieve industry-level functionality while delivering professional quality. Proceed and review the last and third category database. We will focus our review on three main files. The database JavaScript, which serves as a connection point to the database itself. The trip schema, which serves as the schema for the selected collections, and the Travlr API file, which acquires the data from the database. In database review, we will focus on the communication of the front end with the back end functionality. Freshly connected Mongo Atlas database. Stay up to date and provide added value in the form of available data analysis and scalability. Our application will be scaled up to communicate and store its data in the MongoDB Atlas Cloud version database. Moving to the cloud will improve collaborative workflow across developers, productivity, improve security, flexibility, and allow end users to consume data safely in real time. To begin with, we will explore our database connectivity from the database file to database JavaScript. Clearly, we can observe some structure enhancements to be done, such as no longer needed connectivity string to the local host that got modified by the remote connection string, which obscures all the personal information by storing it in the system environment. Similarly, for debugging insecurity reasons, we will display a stripped connection confirmation probe that will be commented for debugging reasons later on. Ultimately, the code tries to connect to the database and catches error upon failed connection. The code also handles gracefully shutdown functionality when the app is terminated and dynamic schema loading to ensure all collections are registered on startup. However, the code could be enhanced by adding connection retry logic block to prevent failure if the database is temporarily unavailable at startup. To enhance our code, we will begin from taking care of the connection string and removing the no longer needed access to the local host and modifying our connection string to the Atlas database. To begin with, we will create a user is minimal privileges such as the Travlr user that is able to read and write to the Travlr database only, making sure is not doesn't have access to any other databases in the system. Next, we can just grab the connection string and update our username and password in this string to make sure the freshly created user will be able to connect to the database securely. From here, after updating our user, we should make sure that the sensitive information is not hard-coded in our code. Hence, a clever thing to do is to disguise this connectivity string directly inside the environment variable and make sure no sensitive information exists in our code. Moving on, we will look at our trip schema file, which serves the travel page as mentioned previously. The trip schema shows an existing index on the code and the name fields, improving query efficiency for lookups and filters. The functionality will prevent full collection scan and searching for trips and improving lookups from ON to O log N by engaging the B-tree indexing and the binary sort. Although indexing requires additional disk space to separate data structures stored on disk, this approach will benefit greatly as the database contains a large volume of records. Similarly, we should consider adding compound indexes to implement filtering functionality, such as searching a trip from the database by price and by trip date. For example, we can create a complex index on the per person field and the start field to run more efficient queries. This index is sorted first by the per person, and then for every identical per person value, it is subsorted by the start date. We can also check and make sure that this index was actually created and is functional by going to the Mongo Compass, the travel collection, and checking the existing indexing. We can see that we have an index on the code field, the name field, and our freshly created index on the per person and start fields. Another tiny tweak and a small enhancement we should do is updating the per person field from a string to a number, as in fact this field is storing numerical values instead of strings. Similarly, we should consider updating our code field and defining it as a unique field. as it serves as the primary key and a unique trip identifier, although such is not inferred as one. To conclude, such enhancements will assist in managing the trade-offs involved in design choices by improving usability, adding business values, improving data quality, and enabling workflows across admins, users, and third parties. Demonstrate practical skills in database design, operation, and development using modern industry tools, and support proven and innovative computing tools and techniques that create modern solutions, provide value, and achieve industry goals.